everyone. This is the fourth lecture of your design of beam. So students, in the last lecture, we have to completed our example up to step number 3. So in the last lecture, we have to completed our example up to distribution factor. And in the last lecture, we have to also cover our step number 2, which is FEM, fix and moment. And after that, we have to cover our step number 3, which is distribution factor. Okay, so whenever we have to design for beam, column, or any component, first of all, it is trial and error method. So at the beginning of this example, we have to assume that the size of beam is 230 cross 300 mm and the size of column is 300 cross 300 mm. And after calculating the I beam, it means moment of inertia for beam and moment of inertia for column, we have to completed our last lecture up to the find out from distribution factor. After calculating the step number 3, the most important step of this example is to find out moment distribution table. So this moment distribution table is just the revision of your semester 5 subject SA1 structural analysis SA2 structural analysis 2, in which when the support is fixed support, then you have to prefer this design. Okay, so our first row is joined, first column, first row is joined. So you can see that there is 4 joint A, B, C and D, but you have to design for only A and B. Then it is already the answer of your C and D. So let us check whether it is right or wrong that we have to design for A and B. Then it is already the design of C and D. Okay, so for A, B, C, D, now there is 3 member coming from A. So there is 2 column and 1 beam. So that 2 column is merged. So over here, these 2 column named as AE and AI is merged. Over here, one beam it is AB. Now from B there is 4 member. First one is BA, 2 column named as BJ and BF, and last is BC beam. Okay, so in similarly same as for junction A. For junction B, there is 2 column named as BF and BJ is merged over here. So now there is only 3 member BA, 2 column and BC. And this is the mirror image from here. So from C, there is 3 member now from 4 because we have to merge all the columns. So CB, column CGCK and CD, and from D this is the mirror image from here. Next step is to return from DF. DF means distribution factor. So students, this distribution factor is find out from here. So you can see that what is the value of distribution factor of AE? So it is 0.412 and AI it is also 0.412. So 2 into 0.412, so it is 0.824. For AB, it is 0.176. For BA, it is 0.139. For column, you can see that in the last lecture that for column BF as well as BJ, the distribution factor is 0.325. But if we have to merge both the column, then we have to merge both the distribution factor. So it is 0.325. And the final answer is 2 into 0.325. So you will get your answer 0.65. And your last value is 0.209, and this value is, you can see that this is the mirror image from here. 0.209, then it is 0.209, 0.65, 0.65, 0.139, 0.139, 0.167, and it is 0.167. It means you have to design for this table over here, and this is the mirror image from here to here. Okay, so students, and one check is this is junction A, and for all the junction the summation of distribution factor is always 1.000. I repeat, for all the junctions, the summation of distribution factor must be 1.000. So you can see that this is 0.824 plus 0.176 is exactly 1.000. It means you have to distribute 100 percentage moment on junction A. If there is some mistake, it is 0.99 and 1.01 like this, then at last you have to suffer some variation in your answer. Then you have to make sure that your answer of distribution factor at all the junctions must be exact 1. You can see that also at junction B that 0.139 plus 0.65 plus 0.209, it is exactly 0.999 is equal to 1.000. Okay, so now the next is FEM. FEM means fix and moment. So this is the second step. We have to find out fix and moment. So our fix and moment first value is MFAB. It means your fix and moment on span AB, it is minus 152.25. For MFBA, it is plus 152.25. MFBC is equal to minus 62.42. MFCB, it is plus 62.42. Now you can see that this value is mirror image from here. Minus 62 point, then it is plus dash dash plus 152.25, then it is minus 152.25. Now what is this dash value? It means there is no any fixed moment on any column. It means you have to prefer as dash, or is it equal to 0? Okay, now our first step is started from here. It is balance, because our all the junctions is unbalanced over here. So first of all we have to balance all the junctions step by step. So you can see that dash means 0 and this is minus 152.25. It means your junction A is having some negative value of 152.25. 0 minus 152.25. So your net moment is also minus 152.25. It means at junction A minus 152.25 moments over there. So you have to balance plus 152.25 moments at junction A for balance a junction. So plus 152.25 into this distribution factor, which is 0.824. So you will get your answer plus 125.45. Now plus 152.25 into this is equal to your answer of 26.80. Now you can see that your moment is unbalanced of minus 152.25, and you have to balance that moment in positive manner. So you can see that plus 125.45 plus 26.80. So the summation of this answer is the opposite answer of this. It means if this answer is negative, then this is positive answer. Similarly, for B junction, 152.25 dash means 0 and this is minus 62.49. So the net moment of junction B is plus 89.83 over here. Okay, so this at junction B, something 89.83 moment is over there as a positive moment. Okay, so you have to prefer that for negative moment. So your negative moment is minus 89.83. So your answer is minus 89.833 into 0.139. So you will get your answer this minus 89.83 into this distribution factor. So you will get your answer minus 58.38, and last minus 89.83 into 0.29209. So you will get your answer minus 18.77, and after this calculation your all the answer is mirror image with the sign change. So you can see that this is minus 18.77, so this is plus 18.77, 58.38, 12.48, and this is minus 26.80. So this is your first step. Second is COM, carry over moment. It means you have to carry over half of the moment. So first of all, at column junction, at column, there is no any carryover moments over there. So your first step is written as 0 on all the column junction. So you can see that this is 0, it means dash, dash and dash. After that, from BA, half of the moment is going to AB, and from AB, half of the moment is going to BA. So you can see that this is minus 12.48, in which half of the moment is going to AB, and from this half of the moment is going to BA. Similarly, from CB, half of the moment is going to BC and half of the moment is going to CB. Similarly, half of the moment going from DC to CD and half of the moment is going to CD to DC. So this is your first step. After finding out the COM, the next step is to find out balance. Now, the calculation of balance. Now, for balance, all the steps is going to repeatedly, because you can see that this is 0 and this is minus 6.24. Now, whenever you're at junction A, your unbalanced moment is minus 152.25 is now your minus 6.25. It means now you have to balance your moment only minus 6.24 as plus 160 plus 6.24. So plus 6.24 into this, so you will get your answer 5.14, and plus 1 plus 6.24, so you will get answer 1.10. Similarly, at junction B, it is 13.40, 0 and 9.38. So your answer is 22.78, but this moment is as positive. So you have to balance it as negative. So minus 22.78 into BA, it means into 0.139. So you will get your answer minus 3.17, minus 22.78 into 0.65. So you will get your answer minus 14.81, and minus 22.78 into 0.209, so it is minus 4.76, and this answer is the mirror image from here. Now the second step is to carry over moment. After that, balance, carry over, balance, carry over. But how much times? So the simple logic is, there is how many spans? So there is 3 span. It means span is equal to carryover moment. It means if you have 3 span, there is the 3 calculation of COM, and plus 1 is balance, then 3 carryover moment and 4 balance. After calculating these 3 carryover moment, And for balance, you have to summation of all these moments. It means you have to summation of all this moment from the below of df. It means distribution factor. So you will get your final moment. So you can see that on final moment, your junction A having column having 132.05 and your AB is minus 132.05. So you can see that now your moment is balanced and your junction A is also balanced. Similarly on B, at BA your value is plus 150.22. At column, it is minus 75.37 and at BC, it is minus 74.59. So you can summation of all these net values, so it is balance. So students, this is the end of your step number 4, which is the most important step, and the name of the step is the moment distribution table. So this is the end of your today's lecture and as well as today's your step number 4, and the next lecture we will carry out our step number 5, which is the column moment, and after that we have to completing and moving further for the design of beam. So this is the end of today's session. Thank you.